Today, on Immunity Group Australia's podcast, we are talking about the universe and science. My great pleasure is to welcome Professor Miroslav Filipović, who is a professor of astrophysics at the University of Western Sydney. Professor, welcome to our podcast.
Thanks very much for your invitation, Nina.
Today is a special day. For the first time in more than 50 years, NASA is sending a mission to the moon. Can you please tell us something about the significance of this mission and why did humanity wait for more than 50 years for another visit to the moon?
Yes, it's a great day for space science. It's long been waited. Yes, we expected this to happen decades ago, that by now we would be in a much better positions to travel far more regular. Nevertheless, 50 plus years later, we are back to the moon. At least, this today's mission will go around the moon and will set up a lot of good ideas on the way how we're going to land back again, on the moon in a couple of years' time from now. It is a very important question why we didn't come earlier. I think it's a classical political questions and the priorities of the humankind in the past half a century at least. So hopefully now we are waking up and hopefully now we are understanding better why exploration of the universe, why exploration of our nearby universe, our next door neighbor moon is very important for our future, for the future of our kids and the next generations. So yes, a great day for us, and hopefully we'll see more and other nations as well, particularly China, maybe even Russia. There, I'm hearing also in the last few days that India is a very serious to go to moon and to conquer the moon. The more, the better, of course, and we'll have hopefully a next generation of humans who will see the moon and beyond the moon in much better eyes than what we did see over the past half a century.
Professor, you're one of the rare scientists who has actually seen how our planet looks like from space as part of another mission. Could you please tell us something about that? How did you end up in the suborbit? And what is the significance of that research as well?
Yeah, well, research that I'm doing is very much connected with things called the cosmic rays. And the cosmic rays are one of the main causes of our death. We know that the humans cannot live longer than 120 years. And if you don't die from a car accident or some other diseases, COVID, eventually you will die in about 120 years. And the reason for that is a cosmic rays, which is coming from the cosmos, mainly from our Milky Way galaxy. So our project was to investigate that from above the Earth atmosphere, and I was connected with the NASA's mission called the SOFIA, and in 2018 I was lucky enough to be chosen and trained to jump on that mission for 24 hours and do our observations. This is, phenomenal mission where we have a spacecraft completely remodeled, put a big telescope at the back and basically observe these cosmic rays, study them to see how we can better protect us and live longer. Nina, do you mind if I ask you actually a question? Would you like to live forever? This is the same questions, for your listeners. And this is the question.
It's a philosophical question, I guess. There would be probably
philosophical. Yes. Would you like to live forever?
I don't think so. If the death looks like it looks like today, but if we could find a way to preserve our age at a certain level and not fall prey to so many diseases, autoimmune diseases, and other diseases which would make us unwell, living forever in a healthy way, looking at a certain age, and not living with disease, I think would be a yes answer for most of the humanity. So under what conditions living forever? Probably that would be
It's a main question. Under what conditions? If I'm God, I would give you the best conditions that you would like to have. The story is that only 20% of human population would like to live forever. This is the Highlander movie, a Hollywood movie called The Highlander, and in that space, this 20% of people who would like to live forever, they always belongs to an older group, younger the people. When I ask my students this question, a very small number of them would say, no, I'm not interested to live forever. I'm happy with what I have at the moment, fearing, for the future, uncertain future. But the older the people, you will get more yeses, yes, I want to live longer, And for that reason, we're investigating why the turtles can live 250 years and why we live only 120, up to 120. Average human life in Australia, I think, is just over 80 or slightly under 80, around that mark. So the cosmic rays is something being produced by a very energetic celestial bodies. This is, something that we investigate and basically looking into a future, what kind of things could suddenly kill us and how we're going to protect ourselves from that. So that was the mission about. The mission is now cancelled as of last year. So we did our great research in this space, and we have a very good clues that if something sudden happens in our neighborhood, in our Milky Way, our galaxy neighborhood, it could have a profound influence on our evolution, our lives as well. Not necessarily bad, maybe it could be good as well. We've seen in the past history of this planet that various nearby events actually changed the path of the way how this planet evolved. Let me just remind your listeners, 66 million years ago, a huge big animals were walking, at the face of this planet. They suddenly died because the small asteroid or comet hit the Earth. Things changed. And then now, 66 million years later, you and me are talking in this podcast. So maybe this is some sort of fertilization. Maybe this is actually good for us to kill us all and start again. Because what we found is, and this is again, one of the research that my group did, is over the past 500 million years, this planet had several massive Earth extinctions. 66 million years ago, when the big animals died, was the last one. And what happened immediately after that, some 100,000 years, even more new species come up, in this planet. Us, there. So I think, this is some interesting way of fertilizations for the universe, for the planet in general. So maybe it's good for us to be completely wiped out and start again. Some people philosophically...
Hopefully not. Hopefully we can find a way to live through, firstly, in Australia, this fuel crisis. We had our Prime Minister talking last night about preserving fuel and doing our due for other our compatriots. But you were part of a group also which discovered such an interesting thing which could perhaps help our energy security. And this is the discovery of a particular particle, ultra-high energy particle. What is this particle, and what kind of consequence could that have for some sort of energy transition in the future if that happens?
So we have a special new instrument which is still under construction in Mediterranean Sea, just south of Sicily. The instrument is called the KM3-NET, Cubic Kilometer Neutrino Telescope. And about two and a half years ago, we were lucky that instrument in its early stages detected a particle, a super rare particle, which we call the ultra high energy neutrino, a muon. What it means? It means that we found a particle with a huge amount of energy. To put you in perspective, if that particle is the size of a ping pong ball, like this ping pong ball here, and if you drop that from a 1 meter height, the energy that it produces there, is absolutely phenomenal. Or if you look into your light bulb there that you see, this particle have a 1 and the 15 zeros more energy than your light bulb there, and it's only one particle. So the trick was to find out, where the particle comes from, and how we're going to catch another particle, and then how we're going to use that for us. This has been regarded as one of the most important discoveries over the last few years, maybe even a decade. The trick now is, as I said, is to find more of these, and they are rare. But then again, another important thing for us is to find where it's coming from. And this is where particularly my group here at Western Sydney University was involved to find where this coming from, what kind of objects produces these things, so that we can control that maybe in the future in our labs, and that way produce the energies that we would need for the future.
There is so much misinformation in the field of science, especially when it comes to space exploration and extraterrestrial life. And you were part of also a group that discovered a new space object called Telios, and there was a lot of misinformation about that as well. Could you please tell us what Telios might be, and how do you as a scientist deal with and teach your students to not to fall prey to misinformation and battle that with real science?
Thanks. It is a very cool object. Teleios means perfect in Greek. And the object that we discovered in our radio observations, radio astronomy, is a field which is an emerging field over the last, I would say, 6-7 decades. And Australia is at the forefront in this research. Interestingly enough, our new radio telescope called the ASCAP, Australian Square Kilometre Array Pathfinder, surveying the sky all the time. And in one of these fields, we detected this very unusually perfect object, perfectly circular object. And as such, that's the object behind me, here in this blue color. That object is very much mysterious in a way that while the universe is somewhat perfect and there is some symmetries, not always perfect, but this object became, very, very perfectly shaped circular. So the question was what it is, and we were very much into finding all the possibilities. One of the possibilities was that this may be an alien civilization. We dismissed that immediately. Let's be clear. It's very, very unlikely that this is due to some alien civilizations. We think, it's some very special Milky Way stars in a very special environment exploded and created such a perfect circle. That provoked also quite a lot of imaginations among the humans all around the planet, talking about, as I said, civilizations, alien civilizations in a war, and the Dyson sphere, which is a sphere collecting the energy, for everything inside of that sphere, and so on. Which I'm not going to say totally impossible, but it's a very improbable, very low chances to happen. So a part of this object, we discovered another 30 objects in the past 20 years using our radio telescopes in Western Australia, the new generations of them. So it's a golden days for us. We are seeing more and more in the new objects all the time, every single day almost.
What is the significance of Australia's geostrategic and geopolitical and geographical, I would say, location? Because a lot of NASA stations and research projects are happening in Australia. And you mentioned in one of our previous talks that Australia does have a special place in the world of astrophysics. Is it our geography, or what is it?
Yes, it's our geography. So we are the most developed nation in the Southern Hemisphere. Southern Hemisphere have a different sky than the Northern Hemisphere. And as political leaders, economical leaders, we are in position to invest the money into this type of a research, which is not the research that can bring the results tomorrow and can solve the problems of petrol and oil in the next few days. But it is a long-term research, and we are the lucky country from a number of perspectives. Yes, geopolitical, but more geo than political is in this case. And we are separated from all the problems, no wars. It's a relatively small population, which is heavily protected. It's great climate, so it's a lot of positives about Australia. And as such, it serves a perfect place to do this type of research, especially in radio astronomy.
What is the significance of Australia's space agency for research in this field? Because I know for a long time there were calls to establish one, and now we finally have one. Has it boosted sort of the interest in the field? Do you have more students now studying? How has it changed, let's say, your research and your life as one of the lead scientists in this field in Australia and globally?
So that's a great question, Nina. Great question, really. ASA, or Australian Space Agency, is not the NASA. It's a very different beast, if it's a beast at all. Did it provoke more kids to look into that direction? No. We have a very different culture now than 50, 60 years ago. Culture is a very different. That culture is similar to the rest of the Western world. When I said Western world, I mean Western countries there. And this space research is not on a level of a hype that we had at the days of Apollo mission in 60s and 70s, maybe even in 80s. It's a very different the way how the modern new generations are thinking, communicating, the way how they see their life. We still get interest, of course, and yeah, we produce great results in that space. I cannot say that really we have a hype time like the 60s and 70s. Science in general is not a popular subject in the Western world, especially among the younger girls. And it's a very complex set of questions. In Australia is one of the countries where the massive shortages, disbalance between the male and the female population is happening. A lot of research are in that space. So space exploration is great. It's imagination, but not many jobs are in this space. The center of Australian Space Agency is in Adelaide, and in Adelaide they managed to create several startup companies, companies which are about to launch the first Australian rocket, sovereign rocket. Again, we're talking about something which was achieved a good 70, 80 years elsewhere. So we are heavily behind, and hopefully things will catch up.
And the international sanctions, in particular against Russia, and the whole tension between US and China in the last sort of 8 to 10 years, has that impacted the global level of collaboration in the space exploration field?
Definitely, yes. In terms of future planning, at the moment we are collaborating. The world is collaborating. International Space Station, for example, is collaborating based on treaties from 80s and 90s. Nothing recently. Everyone goes their own way. The world is polarized. This is a political question which I can talk days. And I'm hearing all the sides. Just a couple of days ago, we had a colleague from Hong Kong who's actually representing China, as Hong Kong being part of China, telling us the Chinese plans of conquering the moon, not just the moon, but Mars as well, which are very serious. But there is no collaboration, even that they would like to do collaboration. So what we experienced in 60s, 50s, and 60s of last century, competition between the USSR and US to some extent produced in this space exploration a good results. That stopped for a good 50 years or minimized. I do see now interest of the big companies to explore the new technologies and to test the new technologies into a space. Let me just give you, if you don't mind me, giving you an example. We are very thirsty for a computers, for a better phones, for a better that space. But there is a price for that, not just an energy, actually mainly energy. You need to cool down these supercomputers. And the best place to do that would be probably into a space. So moving our databases into a space is one of the things that we're going to do in the next 50, 100 years. So the big companies understand that very well, and they are now looking into a way how to place the next generation of computers outside of this planet because it's too hot here. Of course, eventually it will be too hot into a space, and then it's going to be a big question what we're going to do in about few thousand years from now. How are we going to cool down our supercomputers in 1,000 years? But I'm going to leave that to the next generations. I do have some ideas in this space as well, but I think that's one of the great questions that we need to answer in the future.
For newcomers, like you mentioned previously, India, but also I think Saudi Arabia is looking at investing a lot in this space. Is it easier for those new kids on the block in the space exploration space, or is it more difficult?
I would say more difficult. I'm sorry, being a little bit negative in this space. Yes, Saudi Arabia as well is trying to be into this space simply because they do have money. They have a massive profits from their industries, various industries, oil mainly, and they don't know where to spend the money. And the big consultancy agencies are advising them to spend into space technology and space research. The point here is I don't believe that the big companies do have a space, will be a beneficial. Well, they may be beneficiaries, but I don't think that they can do the job. I really think that only a state-based agencies such as NASA can do the job. Only if the state is behind this, then the things can be done. This is the reason why I have a belief that the China and India will do that, because it's a state project. And once when the Chinese put it into their 5-year plan, it's going to happen. No questions, it's going to happen. Again, when? Yes, in the next 5 years, I think we should see a massive new steps into explorations of our nearby space. When I said nearby, this is above our planet Earth, and more into our directions of the moon and beyond the moon as well. So it's going to be a very interesting. And I think the new generations may get inspired in that space. Unfortunately, we have a very different climate now that our kids are growing, and I'm not quite sure how that's going to reflect in future jobs.
It seems that competition in this space is not a bad thing at all.
Always competition is always good, but healthy competitions. We have to emphasize that the healthy competition is good. So we'll see.
Professor, thank you so much for your time, and I hope that many of our listeners who are located in more than 40 countries at the moment will be very much inspired by your work.
Thanks very much for invitations and opportunity to talk about this. All the best to you and your listeners.